Hi and welcome to this SOLIDWORKS tutorial for a spring-driven wooden toy. I'll be creating a motion study using linear springs and linear motors. The assembly parts for this tutorial are available to download from the SOLIDWORKS blog if you'd like to follow along. To begin, I'm going to create the toy's assembly. I've started with this to take you through the mates in place. The mates I'll be adding are to position the parts, but also to help the motion study run more smoothly. Opening all of my components, I'm going to check the Keep Visible pin. And with the floor part selected first, I'm checking the green tick here, which places it centre to the assembly's axis. Then I'm dropping in my parts in order. The plant part will sit almost centre to the floor. Then I need the 3 flowers, the daisy, tulip and violet. And finally 3 of the spring discs. Then, when checking the pin, I can check the tick to close the Insert Components feature. Selecting the mate icon, I'm going to mate the top face of the floor coincident to the base face of the plant part. Then, viewing from the top, I'm moving the plant pot to the centre of my floor. I don't need to be too precise with this. The floor part is big enough to catch the flowers when they pop out, so I'm just moving it by eye. And then right-clicking the plant pot in the parts list, I'm fixing the part. So now both the plant pot and the floor parts should be fixed and unable to move in my motion study. Turning on section view, I want to be able to see inside of the plant pot like this. I'm flipping the direction so that I can mate the flowers in place. I'm mating each stem into the slots with a concentric mate. Then I'm adding a coincident mate between the bottom face of the stem and the inner top face of the spring cavity. With all 3 flowers in position, I'm also adding parallel mates to the flower face and plant pot. I'm only adding these to keep the flowers forward facing while I'm mating parts. Turning off the section view, I need to move the spring discs into a position that makes it easier for me to mate them when I turn section view back on. For these, I'm adding 2 mates each, a concentric mate to sit them into the spring cavity, and a coincident mate to place them at the top of the cavity like this. With all of my mates applied, I'm renaming my mates to make them easier to distinguish between. I'm naming the concentric mates of the flowers, the flower name and stem. The coincident mates for the flower stems are being renamed to the flower name and temp, as these will be temporary mates in my motion study. The concentric mate for the spring discs are also renamed with the flower name they are below and spring. Doing this makes a slightly fiddly motion study clearer, especially when mates play a role in the study. Next, I'm making the temporary axes in my assembly visible, as these will be used for motor directions. I can save my assembly ready to start a motion study. Selecting my Motion Study 1 tab here, I can change my study type to Motion Analysis. I'm disabling the playback of view keys so that existing orientation and camera view key point views are ignored in the animation. Then under the Settings icon, I'm checking the Use Precise Contact box. This makes the contacts in the study more precise, but it can also slow down the calculation time. Then the most important elements I need in place is gravity along the y-axis like this. Then adding solid body contacts, ensuring all bodies are selected. I'm not changing the material settings, just adding them as they are. I'll be keeping my motion study length at 5 seconds. Now I can begin adding the springs. Turning on section view to see the cavities, I can select the spring icon here. With my spring type on linear spring, I need to select the spring parameters. which are between the bottom face of the spring disc and the bottom face of the cavity. You should get a little preview of what the spring looks like, but this is just a temporary visual. For the spring settings, I'm keeping the spring constant on 1 Newton per millimetre. I'm not changing any of the other settings and confirming the spring. I can then repeat this for the other 2 spring cavities. Turning off the section view, the next feature I need to add are motors. I'm adding motors to mimic the effect of pressing onto the flower and then releasing it to spring out of the toy. Changing the motor type to linear motor, I need to choose a component. For this, I'm selecting the tulip flower. Then I can select the tulip stem axis for the motor direction. I need to flip the direction downwards like this. Then I can change the motor type to distance. I'm going to push the flower down by 14mm. I can keep the start time at 0 seconds and the length of time it takes to push the flower down by 14mm to 0.15 seconds. Next, I can add another motor to the violet flower, repeating the previous settings. Only this time, the start time will be after the first flower has sprung out of the toy at around 1.2 seconds, again for 0.15 seconds. For the third flower, the daisy, I'm adding a final linear motor. This motor will start at 2.4 seconds and again last for 0.15 seconds. Once all of the motors are added, I'm going to rename them with each flower name, making it easier for me to distinguish between them. The next few steps can get a little complex, so follow carefully. I'm dragging this window up to see all of the mates, while still having the motors in view here. The first thing I need to do is select the parallel mates and the 3 coincident mates holding the spring discs still and suppress them all. I did this ensuring I was at 0 seconds. Moving my time bar to 0.6 seconds, I'm turning off the motor for the tulip flower and at the same time point suppressing the tulip concentric mate that holds the flower concentric within the slot. By keeping the concentric mate active during the time the motor is on, I'm stopping the flower from tilting within its hole, which speeds up the study calculations. But this needs to be switched off at this point to stop the flower landing back into the hole, instead allowing it to fall onto the floor. For the tulip's temp mate, I need to move my time bar to the start and suppress it, to allow the flower to move away from the spring disc once it's pressed down and released. Moving on to the violet flower, I'm moving my time bar to around 1.2 seconds and then dragging the start key of the violet motor to my time bar. This is when my motor will turn on. Dragging the time bar to 1.8 seconds, I am right clicking the motor and turning it off. At the same time point, I need to suppress the violet stem's concentric mate. Then dragging the time bar to when the violet motor starts, I need to suppress the violet temp mate holding the stem coincident to the spring disc. Again, the concentric spring mates stay on throughout the analysis. Dragging my time bar to the 2.4 seconds mark, I'm moving the daisy's motor to the start at this time point, and then turning it off at 3 seconds like this. While I'm here, I can suppress the daisy stem mate too. Then dragging back to the 2.4 seconds mark, I'm suppressing the daisy's temp mate. Again, I don't need to make any changes to the daisy's spring mate. With all the settings in place, I can drag this window down to see my assembly. I can resave the model, and then I can select the calculate icon here. This may take a few minutes or a little longer depending on your system to fully calculate. I have the playback while calculating option on so that I can watch the result of my analysis as it calculates, just in case there's any issues or things that aren't moving the way I need them to. I will be able to cancel the analysis and make the changes. Once my analysis has finished, I can play it back. I used the SOLIDWORKS Visualize add-in to export the motion study directly into Visualize to render this final animation. I hope you enjoyed this tutorial. Thank you for watching.